There's been a lot of Conway's life discoveries since that Scientific American cover that we saw, even new discoveries since the last G4G, meaning one of them was extra relevant, and that meant this talk had to happen this year. For anyone new to Conway's Game of Life, are there any in this crowd? Probably. Just start with an infinitely large checkerboard, if you can find one. Put some checkers on it, and except they're called cells because the game is called Life. It's a zero-player game, so once you've dropped the cells onto the board, hands off, you just have to see what happens. Everything is emergence from there. All that the rules of Life actually say is that on each turn, new cells will show up on any square if there are 3 existing cells next to it, 3 neighbors if they get to survive, if there are 2 cells or 3 cells, and otherwise they die and disappear. That's all the rules. When those rules were first being invented back in 1969, John Conway and his crew of graduate students and hangers-on tried out different rule candidates, partly by seeing what happened to polyominoes. Under Life rules, the small ominoes all went boring pretty quick. If they didn't just die out completely, there'd be a little bit of maybe activity, but then they just twitched back and forth. Not a lot of excitement. Looked like kind of a dull rule. Then they tried this one last of the 12 pentominoes, and suddenly a lot of stuff started showing up, including these moving things, gliders. Once a pattern moves and repeats itself once, it's bound to keep doing the same thing forever. The rules are the rules, unless something else comes along and crashes into it. Inevitably, somebody started aiming gliders at other gliders, starting a new field of recreational math research, glider synthesis, crashing gliders together to build interesting things. This was a key piece of a lot of early proofs of Life being computational universal, equivalent to Turing machines and so on. Crashing more gliders together produced more stuff, and that snowball's been rolling downhill for over half a century now. So now we know how to build really complicated stuff. And that was a doodah spaceship getting constructed with 34 gliders and destroyed again by 1 more. Once Life enthusiasts come up with a first solution to some problem, we usually can't just leave it alone and enjoy it. We start asking optimization questions. Can we make it faster? Can we make it smaller? Can we make it more efficient? Can we build that doodah spaceship with less than 34 gliders? The answer turns out to be yes, we can, but it's really complicated. This is the next part of the story. Another polyomino that also showed up early in the history, 1971, when Charles Corderman was playing the role of Dr. Frankenstein in the history of Life, setting up bigger and bigger polyominoes and breathing life into them to see what happened. This one went kind of wild. This one just happened to turn into a small pattern that evolves into its own mirror image in 48 ticks and leaves a mess of other stuff behind it. It's almost self-sustaining. You just have to bump it a little bit, and it will keep doing that forever. These patterns are called switch engines, and they travel exactly 1/3 of the speed of a glider. That means that a glider can get bounced back and forth between an oncoming switch engine and a stationary point. And each time it does it, it'll take exactly half the time of the previous cycle. That's really improbably convenient. Conway had no idea that switch engines even existed when he picked Life's rules. But there they are, and they're just the right speed, and we can build them with just a few gliders crashing together. It turns out if we write a string of 1s and 0s and interpret that as a binary number, we can use that number to calculate a location for a switch engine. Then we can set up a mechanism to bounce a glider off that switch engine, get exactly those 1s and 0s out of this stationary spot where the glider bounces back. Those can control a construction arm, and the construction arm can reach around. It's all made out of gliders, and send other gliders anywhere on the Life plane that we want. This trick is called the reverse caber tosser, and RCT for short, for reasons that I have absolutely no time to go into. We can use this trick to build any object that can possibly be constructed with gliders in life, even if the object would ordinarily take thousands of gliders, millions of gliders, whatever. We can always build the same object with just a fixed small number of gliders, because we can encode all the construction information in the big initial distance. All we got to do is build the reading mechanism, same one every time, so same cost for any possible pattern we might want to build. To make that work, we start with 4 gliders off in the upper left corner, as I showed. 4 more gliders in the southeast corner, 7 more down in the southwest corner, sending out streams of gliders that interact and do this trick. You all may or may not have noticed that the total number of gliders is ridiculously small and amazingly auspicious for this G4G. If you can build a life pattern by colliding any number of gliders, you can also build that exact same pattern in a completely unreasonable amount of time with this completely unreasonable RCT method with 4 and 4 and 7. All you ever need is a whole lot of space and time and exactly 15 gliders in all.